Hello students, welcome back to Chemistry Online class brought to you by iGotel Virtual Learning Platform. I am Olabisi Olawaye and I still remain your chemistry facilitator. Today we'll be looking at a very important topic in chemistry, which is still the part B or part 2 of the introduction to chemistry, and that is the scientific method. You might be wondering how scientists achieve most of their, theories and laws that they propound or circulate all over the world, and how they manage to get all their researches together to get a particular theory. Actually, there is a step, or there are steps scientists follow to solve any problem they come across and get something reasonable out. So at the end of these teachings, you're expected to know the meaning of scientific method, those steps in solving problem, the scientific method itself, the difference between laws and principles, the difference between laws and theories, and also be able to apply this scientific method to solve any problem you come across or anything new you want to learn. So the scientific method is the process of establishing facts through testing and experimentation. You carry out testing and experimentation severally before one establish a fact, and it is known as a series of steps followed by scientific investigators to answer specific questions about the natural world. Now, most of the theories and laws that are being circulated, like the Newton's law of motion, the John Dalton atomic theories, and so on and so forth, the law of magnetism, Le Chatelier's principles, and so on, all these were based on these steps. Now, the question is, do scientists follow these steps strictly? No. And yes, there are some research or problem that may not suit this case. So in that case, a scientist may have a reason to modify or remodify these steps in order to, but they still maintain the culture. That's recording and doing experiments to carry out and to get their conclusion, to draw their conclusion from and get their results. And it is very important as a scientist to get all the materials you need. Reporting or writing reports is very, very important as a scientist. And as a student, you may end up being a scientist. You should also be computer literate, because most of these results are sent online through journals and or through meetings, scientific meetings, in which one's journals may be circulated and others may work on it. So as a scientist, we must be curious, open-minded, and we should be observant. So what are those steps in solving scientific problem? The first one here is observing a problem. That's when you observe and you do you start asking a question. Maybe you observe something that is unusual. Maybe you left a nail or iron spoon outside the compound, and mistakenly, or a cutlass, brand new cutlass, was left for days, and then after 4 days you now notice that the cutlass has changed color to brown, and it has a brown substance on it. And then you begin to ask question: what poured on this cutlass? What must have happened to this cutlass. Then you begin to do background research. That did anybody had any strange substance? Was there rainfall? What happened actually? Or was there anything wrong with the cutlass or spoon before being placed outside? So from there, you'll be able to, the first thing is asking a question when you observe a problem. Then you do background research. Then the next thing is you construct an hypothesis. What does an hypothesis mean? Hypothesis means a reasonable guess. A reasonable guess. Then you begin to guess and you write down your hypothesis. Like, okay, maybe this formation of brown substance which is rusting is as a result of the sun or the water or the air. What could have happened? So you guess and you'll be like, okay, this is what is happening to the metal. It could be the rusting could be as a result of sunlight, water, or air, and you are not so sure. But at this point, this hypothesis will not reach anywhere. You need to carry out an experiment. That is where testing with an experiment will come in. You carry out an experiment. Setting up an experiment also requires some knowledge. Like when you are setting out an experiment, you consider that what you are testing for, you want to detect what caused the formation of a brown substance on the iron metal that you placed outside. And then you know that water, there was rainfall, maybe the substance was exposed to water, but you're not sure because the material inside the house too were exposed to water, but nothing else happened. Nothing happened to them. There was no formation of brown substance on the iron spoon or cutlass inside. Or could it be that there's something else that is responsible for this formation of brown substance? So having done research, you already know what you are looking for. You construct an hypothesis that, okay, I want to test if only water is responsible or water and air is responsible for the formation of rust. So testing with an experiment must be well reported, and there are steps that you need to take when you are reporting your experiment. As a scientist and as a science student, when you are setting up any experiment, the aim or title of the experiment must be well written. Okay, the aim is to test if only water, if air, or to test what is responsible for the formation of rust. That's a brown substance on the metal. Now, the materials used will be written down, then, and the reagent or chemicals used as well. Then the next one is the procedure. After the procedure, that's the steps you took in carrying out the experiment. Then the next one is after the aim and title, we have the materials and reagents. Then we have the procedure. Then the next one is the observation. After your experiment, what did you observe? Then from the observation, you can draw conclusion about your experiment. So you might be wondering, this is how, before I move on, this is how we report any experiment done as a scientist. Even in the laboratories as biology or science students, for chemistry, practical for instance, you carry out the procedures, you follow, you know what you are testing for, the titration of acid against base, the materials needed, the steps, then what you observe, the base, the color of the solution in the conical flags changed, and then conclusion. So you should have this at the back of your mind, though all experiments may not follow these steps. And I'm going to explain more about all this network or this chart. Actually, the major steps in scientific methods are observation followed by questions. Observation, question, then formation of hypothesis, which is a reasonable guess. Then we have the experiment. After the experiment, we have the analysis of results, and then your conclusion. But to explain this better, I will use this chart to explain better. And then after asking a question, you observe a problem, you do background research, you carry out hypothesis, then you set up an experiment. Now look at this. If the test, if the procedure is working, if it is yes, if the procedure used for the experiment worked, if it is yes, then that is you notice that when you expose the spoon or iron material inside, you expose it to water, then the one outside you expose to water, but the one inside, nothing happened to it because you closed everywhere, air did not enter. Then the one outside was exposed to moisture, which is also water, and it was kept wet for long, and it was exposed to the air as well. You notice that there was a change in the iron spoon outside compared to the inside. So it means your procedure is working. If it is working, then you can analyze your data and show that, okay, let me draw conclusion from this data. And in some experiments, you may have to take the readings or some values down. Then when you're analyzing your results, you can use several measures to analyze. You can use graph, a colorful graph under Excel. You can use other tools like the SPSS to analyze your results and get the major points out to be able to defend it better. So from there, you draw conclusion that, okay, apart from water or moisture, I think air is also part of the materials that or part of the conditions that brings about rusting. So if yes, you analyze your data and draw conclusion. From there, if your results align partially, you compare it with your hypothesis or not at all. If it aligns partially or not at all with your hypothesis, you will have to remodify your hypothesis. You remodify it or change, or you go back to the hypothesis, change the hypothesis and go back to the experiment. But if that is in that case, now it will not work. It is a theory, and in that case, your experimental data that you have done become background research for new future projects to work on them. You can now ask new questions to form a new hypothesis and then experiment again. Now, and if your results align with your hypothesis, you can communicate your results. In this case, you get your theory properly. And on this side, if the analyzed data did not align with your hypothesis, it is not yet a theory. If it works and the results align with your hypothesis, that is, it correlates with your hypothesis, the reasonable guess at the beginning that, okay, after carrying out your experiment, you notice that you got the answer that, okay, apart from water, air is also part of the condition for rusting. Then you can communicate your results through writing of journals, send it to scientists all over the world on the internet. You can also read it, and when there's a scientific gathering, you can discuss your results, and other scientists can also build on it. Now, at this stage, it is a theory, but if it has not passed this stage, if it has passed this stage, so other scientists can work on it severally until they get other principles or law. So theory is different from law. When series of experiment has been carried out on a theory, then it can become a law or principle. So you get a law or principle from theory when theory is being modified. Now, at this point, if your procedure did not work, you carefully check all the steps in the experiment and the setup to detect any mistake. And if there's no mistake, it means you have to reconstruct another hypothesis and also carry out another experiment. So what's the difference between laws and theory? Just like I've said, a theory is the explanation of why a process occurs. A very good example is the Dalton's atomic theory. Now, a scientific law is a description of the phenomenon observed. That's like, for instance, under Newton's laws of motion. A scientific law is formed from a theory after carrying out various experiments. It is also a statement that explains the working of a process. Now, that's the first question I want to ask you. How is an hypothesis different from a theory or law? How are they different? How is an hypothesis different from a theory or law? These are questions you should ask yourself. You should know here that an hypothesis is a reasonable guess which has not been subjected to experiment. A theory is the explanation of why a process occurs, why the law or principle is derived after a series of experiments has been carried out on a theory. Now, I'm going to ask you this question and I want you to answer it. It will serve as an evaluation of what we've done so far. Then I will come back to discuss the answer. Can a theory be derived from a law, or is the opposite true? Number 3, how do scientists develop theory? This will take you back to the steps from the beginning. Welcome back to the platform. So let's treat the question. Can a theory be derived from a law, or is the opposite true? Actually, is this a law that can be derived from a theory? Theory is not totally true, but when it is built upon, it becomes a law after a series of experiments has been carried out on it. And another name for law, or another ground for law, is a principle. Now, how do scientists develop theories? They start with observing. They observe a problem, then they ask questions. That leads us back to the steps. How do scientists formulate theory or develop theory? They start with observation, then they ask questions, and then formulate hypotheses. From there, they carry out the experiment, analyze their results, and conclude from their analysis. And from there, they get their theories. And theories can be built upon to get law. If the theories are not aligning with the hypothesis, it is remodified. The hypothesis is remodified or cancelled, and another one is formed. This brings us to the end of our class, and I would advise you, if there's any aspect that you don't understand, you can send your question to me. And I want to commend your effort. You really tried cooperating and, participating fully in the class, paying attention. And I want to advise you not to relent in your effort. These topics and the videos have been carefully selected to help you pass your exam properly. So please do well by treating your questions, past questions, especially your WAEC past questions. And you can get this from My School Gist online on Google, and get your past question as well to treat more questions in chemistry. It will help you to build your confidence, and also get you exposed to the way WAEC asks questions. And I can recommend some textbooks for you. That's New School Chemistry by Oseyo Ababio. It's recommended that you go through it. Then the Chemistry Practical Manual by G.O. Ojokuku is also recommended. You can go through this. It will help you as you study for your exam. All the best.